Factors, multiples and primes. Okay, factors are numbers which can divide a given number exactly without a remainder. For example, a factor of 36, a number you can divide 36 by exactly, is 2, because if you divide 36 by 2, you get 18. There are other numbers, just a simple example. Now, prime numbers are special numbers that only have two factors, 1 and themselves. So, for example, 7 is a prime number because the only factors it has are 1 and 7. The only numbers you can divide 7 by are 1 and itself. Multiples are numbers found by multiplying a certain number by a whole number, or basically numbers in the times table for that number. 48 is a multiple of 8 because it's 6 times 8. Similarly, the first four multiples of 7 are the first four numbers in the 7 times table. So 7, 14, 21 and 28. Okay, so write down the factors of 48. Now, the best way and systematic way of doing this to make sure you get them all is to start simple. So 1 goes into 48. How many times does 1 go into 48? Well, it goes into 48 times. Keep counting up. 2, does 2 go into it? Yes. 2 goes into 48. How many times? It goes in 24 times. 3, does 3 go into it? Yes, it does. 3 goes into 48 16 times. Does 4? Yep, 4 goes into it 12 times. Does 5? No, 5 doesn't go into 48 at all. About 6? Yes, 6 goes into 48 8 times. 7? No, 7 would be 49. How about 8? Well, 8 goes into 48 6 times, but if you look, we've already got 8 written down here. Now, because we've written it this way, we've actually, as soon as we've got to the number that we've already written, it means we've found them all. So the factors of 48 are 1, 2, 3, 4, 6, 8, 12, 16, 24 and 48. Now the way I've written them is really in pairs, and we call these pairs factor pairs. That's because if you multiply the two numbers together, you get your number. So 1 and 48, multiply them together, you get 48. 3 and 60, multiply them together, you get 48, and so on. Other one, write down the factors of 36. So we're going to do the same thing again. Start simple. 1 goes into it 36 times. 2, yep, that goes into it 18 times. 3, yep, 3 goes into it 12 times. Does 4? Yes, 4 goes in 9 times. 5? Nope. How about 6? Yes, 6 goes into it 6 times. So we actually get the same number twice, so we can ignore the repeat. Thinking about why we get a 6 twice, well, 36, we saw it in the last category, it's a square number. It's 6 times 6, so we only actually have these 4 factor pairs and then one number that's repeated because it's a square number. So the factors of 36 are 1, 2, 3, 4, 6, 36, 18, 12, 9. Okay, write down the first 10 prime numbers. So we're looking now for the numbers that can only be divided by 1 and themselves. Now do not get caught out, do not start with 1. Yes, 1 can only be divided by 1 and itself, but 1 is not a prime number. It has to have 2 factors, so we're going to have to get rid of that because 1 only has 1 factor itself. So the next prime number is 2. 2 can only be divided by 1 and itself, so 2 is a prime number. Keep going. 3, yep, 3 is a prime number, can only be divided by 1 and 3. 4 isn't, you can divide that by 2 as well. So how about 5? Yes, 5 can only be divided by 1 and 5. 6, well, 2 and 3 both divide 6. How about 7? Well, we've already seen that 7 is a prime number. Next one's 8, no. 9, no, they can divide that by 3. 10, no. Next one is actually 11. 12, nope. How about 13? If you keep going in a similar vein, think about whether you can divide it by anything other than 1 or itself. Next prime number after 13 is 17, then 19, then 23, and 29. You don't really need to learn these first 10 as prime numbers, you just need to be able to recognise why they are prime numbers. And most important of all, don't get confused with 1. 1 is not a prime number. Okay. Interesting to note that as well, it's not just the odd numbers, because odd numbers can be divided by other odd numbers, and 2 is the only even prime number. Okay, another example. This is pretty much a standard exams type question. You've got a list of numbers. From that numbers we want to identify first a factor of 21. So what number can divide 21? Well, looking at this, clear to see the only number we can divide 21 by is 7. So 21 divided by 7 is 3. A prime number. Looking for a number in that list which is a prime number. Well, there's 2. 7 we've just written, but we'll use a different one. We'll use 2. 2 is also a prime number. A multiple of 5. So that means we want something that's in the 5 times table. And we can see from that the only one that's going to be is 15. That's 3 times 5. Now, 2 numbers that sum to 33. Sum means that they add together to give 33. So, well, it's not going to be 22 and anything. We'd need 11. We haven't got 11. How about 18 and 15? Yeah, if we add those together, we get 33. So it's 15 and 18. Best way is just to look through. It won't take too long to just figure out which numbers it's going to have to be. And finally, a square number, so it's linked to the last category. Which of those numbers is a square number? Well, there's only one in there, and that's 4, because that's 2 times 2.